every module is slightly different. You can create a gradient of sizes, scales, and that for a 3D printer, printing one module that's different than the next module, it doesn't matter to them. But if you build it traditionally in an assembly process, you would want all the modules to be exactly the same. Where in 3D printing, that complexity is not difficult.
We're working with machines that can actually variate the material in a digital way. Right? What that means is that your traditional 2D printer would actually change the pixels of colors, right? Like you have different colorations, and that ultimately becomes an image. Stratasys is able to do that digitally with materials in 3 dimensions, right? That means that you can actually have a translucent material, something like glass almost, or transparent, and go to something opaque. You can go also from something that is soft and flexible to something that is strong, or something that has one color to another. So these are all different spectrums and ranges that you can work with, right? And the machines that we're using can definitely allow us to variate this in different parts of the design. So we can just, as designers, we're completely free to explore these digital materials.
In the past, the advantages have really been about resolution and quality of the model. In the present, it's about the kinds of innovations they have in terms of their multi-material, multifunctional material, color-based material approaches, as well as size and again, accuracy.
And with FDM, one of the advantages of FDM is that the material is long-lasting, and it's real thermoplastic. But what's amazing about PolyJet is the range of colors that you can do. So we're also working on printing kind of patterns and colors onto the pieces.
And I think that is what we find most compelling about the PolyJet materials, is that we can have a palette that not only expresses difference in terms of color steps and color gradients, we have things that can produce differences in terms of rigidity and stiffness and softness, and also transparency and opaqueness and translucency, and find a whole variation of color combinations, material properties, and other things that can actually produce a really wide range of articulate designs.
For my smaller items, I'm working with Solidscape, which is also a Stratasys company, on the metal printing. So they're printing it actually in 3D printed wax and then casting it in silver. That has been a really kind of amazing results because of how perfect the kind of wax model is, and translates into a really beautiful metal ring.
In general, what 3D printing has enabled me to do is to rapidly prototype very complex designs, and to be able to take it out of the computer from digital to analog, hold it, experience it at scale, and therefore be able to iterate more quickly, which is what designers need. You need to iterate rapidly to improve a design, and architecture is a complex problem. So it allows us to feel, see, sense, and adjust very rapidly.
I do think it's moving through high volume actual production of actual usable consumer parts. And if you think about what can happen with the entire consumer industry, and we can begin looking at no longer mass producing items, but mass producing on demand, meaning that we are able to produce a line of products which don't have to be stored, they don't have to be packed, they don't have to be shipped, they don't have to be sent anywhere. They exist purely as digital files, and when you want a digital file, you download it. More so, you have the ability to modify it and actually potentially recustomize your own piece, print your own piece that the designer has given you certain privileges or allowances to work with, and therefore the designer is still retaining the authorship of the piece, but you are getting your own customized version on demand.
It's been selling really better than I thought it would be for a very new product, and people are very open and kind of amazed at the technology and the kind of level of detail that you are able to achieve. And just be able to create such a bold statement on your body is something that there's just not jewelry quite like it.
3D printing is clearly a major component to the paradigm shift, which we might call complexity is free, or the infinite computing paradigm, where we can simulate in the computer really, really complex things, But now we can not only simulate those things, but we can rapidly prototype, rapidly make. And so it's really just I think we're somewhat on an exponential curve of possibility. We're really just at the beginning